What's going on, everybody? Got another video here for you. This is a video for an applied calculus class, applied calculus 2, the second class, and this is solving linear differential equations of first order. So how do we do that? The last video was separation of variables. This video we're going to use the integrating factor. All right, so it's not difficult to do. It's pretty easy. You just got some steps you have to follow, and I'm going to show you down here the steps, and we'll work several examples. So it says a first order linear differential equation is an equation of this form. So what we've got to do is we've got to be able to get our differential equation in this form right here, this one right here. Okay, that's what we're going for. You got dy dx plus p of x times y equals f of x, and p and f are continuous functions of x. And this first order linear differential equation, this is what we call standard form. This is the form we're going to need to get it in order to solve it. So let's look. Solution of a first order linear differential equation. So here's the steps. There's 5 steps to solve it. If you are in my class, I will give you this for the test. Okay, I'll give you the 5 steps. So all you got to do is be able to, you just got to learn how to apply these steps, and you shouldn't miss a problem. All right, so to solve a first order differential equation, first we want to put it in standard form. So put it in this form right here. Identify p of x and find the integrating factor. All right, so remember, p of x, that's the function in front of y. All right, and we find the integrating factor by taking e raised to the integral of p of x dx. This is our integrating factor right here. And then we want to multiply the equation by the integrating factor. The equation we have in standard form, multiply it by the integrating factor. So you got to make sure you put it in standard form. The left side of the equation in step 3, that's after we multiply, is the derivative of the product of the integrating factor and the dependent variable y. So in other words, we've got d dx, the derivative of this with respect to x, is equal to this over here. So I will explain this more when we get into the examples. I'll show you more about this. Okay, but just know, once you multiply it through by the integrating factor, you can write the left hand side like this right here. Okay, and I'll explain that in more detail when we get to the examples. And then we just integrate both sides of the equation that we get in step 4. All right, so let's look at our first example. All right, so to solve this, first thing we need to do is get it in that form. So you see we've got the function p of x in front of y. We've got f of x right here, but we've got the dx and the dx, so we need to get rid of that. So we're going to divide each term by dx. And so this is dy dx plus 2 over x times y equals 4x. All right. And so let's get our integrating factor. So we have, let's see, where do I want to do that? I guess we can do it right here. I think we'll have enough room. So we've got p of x is equal to 2 over x. Remember, p of x is the function in front of y. So that's 2 over x. And now for our integrating factor, that is e raised to the integral 2 over x dx, which that is equal to e raised to the natural log x. All right. I'm sorry, 2 natural log. Because remember, this 2 over x, that's the same thing as 2 times 1 over x. And if we integrate that, we can bring the 2 out. The integral of 1 over x is natural log, and then we multiply by 2. And so this is going to be e raised to the natural log x squared. Remember, there's a property that says we can take that 2 and pop it up there in the exponent. And so this is equal to x squared. So remember, you have a property from algebra that says the log with base b of b raised to the x is equal to x. So in other words, if the base of the log and the base of the exponent are the same, then your answer is your exponent. And what we have here is we have well, I'm sorry, that's a different property. That's not the right one. Let me write the right one there. B raised to the log of x with base b is equal to x. So it's the base of the exponent, the base of the log. If they're the same, then your answer is what you're taking the log of. So what we have here is we have e raised to the natural log of x squared. Well, remember, the natural log of something is equal to the log with base e. So this natural log here, that can be written as log base e. Now, you're not going to have to show this step. I'm just doing this so you can see it. And I'm not going to do this on every problem. Okay, but just understand, when you see natural log, you picture a base e there. That's log base e. And so now you can see that e is the same. And so our answer is just what we're taking the log of. And so that's where the x squared comes from. All right, so what does it tell us to do now? Well, now it says to what? Multiply everything through by the integrating factor. So I'm going to multiply everything here by the integrating factor. And so that's going to give me x squared times dy dx plus x squared times 2 over x times y equals 4x times x squared. So that's going to be x squared dy dx plus what is that, 2xy, the x's will cancel, equals 4x cubed. All right, so there we have it. Now this is where we're going to look at this this step 4 here, this left hand side. All right, so this left hand side we can write as dx times, and that's going to be x squared times y. And that equals 4x cubed. All right, so remember what it said in step 4, that the left-hand side is the derivative of the product of the integrating factor, which is x squared, times the dependent variable y. All right, so let me show you. Let me show you just a little more with that. So if we have this left-hand side here, I'm going to show you how this works out. So what happens if I take the derivative of this? Well, this is the product rule, right? So it's going to be the derivative of this is the first function times the second. So derivative of y, that's dy dx, plus the derivative of the first function, which is 2x, and then times y. And you can see when I take the derivative of this right here, I end up with this. And that's all they're saying, is that once you multiply both sides by that integrating factor, this left-hand side here is going to become the derivative of the product of the integrating factor and the dependent variable y. So all I'm doing is I'm taking this left side and I'm rewriting it as the derivative with respect to x of the integrating factor times, which is the x squared here, times the dependent variable y. And that's what you do for step 4. That's what that's talking about. All right, and then what does it say to do? Then it says integrate both sides. Let's see, where is it? Integrate both sides of the equation found in step 4. All right. So if I integrate, with respect to x, all right, so I've got the integral of a derivative, so that's just going to be x squared y equals, and then this is going to be x to the 4th, that's just your basic power rule, plus c. And then what we're going to do is we're going to divide everything by x squared. And so now I get y is equal to x squared plus, and then this is c over x squared, which I could write that as c times x to the negative 2. And this is your answer. So you can see it's not that bad. Okay, I'm not going to spend as much time on every example. I just wanted to show a lot of detail on the first one, especially this part right here. Okay, so you can see how that works out. All right. All right, so let's take a look at this next example here. So first thing we want to do is we want to get it in that standard form. So I'm going to divide everything by x dx. All right, so that's going to give me dy dx minus, and that's going to be what, 3 over x times y, and then that equals x squared. All right. All right. So let's see what we get on this one. So this one's going to be similar. So for this one, what is p of x? Well, notice one thing, that standard form, this was plus. So this tells me that p of x is equal to negative 3 over x. So our integrating factor is e raised to the integral negative 3 over x dx, which this can be written as negative 3 times the integral of 1 over x dx. I can just pull out the negative 3. And so that's going to be e raised to the negative 3 natural log x, which is e raised to the natural log x to the negative 3, which is x to the negative 3, which is equal to 1 over x cubed. I don't know. We might want to put it as 1 over x cubed. We may want to leave it like this. I don't know. We'll just have to see once we start multiplying everything. All right, so let's see what we get here. So we've got, let's see, multiply this by, I guess we can go ahead and just leave it as 1 over x cubed. I guess that'll be fine. And so we get 1 over x cubed dy dx minus 1 over x cubed times 3 over x y equals 1 over x cubed times x squared. And so now let's see what we get here. 1 over x cubed dy dx minus 3 over x to the 4th times y equals 1 over x. All right, so let's see, what does the left hand side, it's going to become the the derivative, well, all right, it's going to be the derivative with respect to x of the integrating factor, 1 over x cubed times the dependent variable y, and that's going to equal 1 over x. And so if we integrate both sides, 1 over x cubed y dx is equal to the integral of 1 over x dx. So this is just going to be 1 over x cubed y equals the natural log of x plus c. And so now we just get y is equal to, and you know, we can take that, we got to multiply everything through by x cubed to get rid of that fraction. We can multiply it to each term, or we can just leave it like this. And this would be your answer here. All right. So that's that problem. All right. So let's look at the next one. So for this one, I'm going to need to, let's see. Well, here I just need to divide everything by dx, don't I? So this is going to be dy dx plus y, no dx, plus y equals x. All right. All right, so let's identify p of x. I'm going to do it up here. So let's see, p of x is equal to 1. And so now our integrating factor is equal to e to the integral 1 dx. All right, so here we get e to the x. So when we integrate the 1, we just get an e to the x. Okay, so let's see what we got here. So now I need to multiply everything by e to the x. So that's going to be e to the x dy dx plus e to the x times y equals x e to the x. All right. So now we've got this left-hand side is the derivative with respect to x of the integrating factor times the dependent variable y equals x e to the x. And then we integrate both sides. Whoop. Left off my dx there. Equals the integral x e to the x dx. All right, so this one seemed like, hey, this is going to be an easy one because p of x was just a 1 instead of, you know, something like we had at first. But actually, let's see, what do we got to do here? So let's go to the side and let's do the integral x e to the x dx. So what do we got to do here? Well, let u equal x, dv equals e to the x dx, integration by parts. So du is equal to dx, v is e to the x, and so this is going to be x e to the x minus the integral e to the x dx. So this is going to be x e to the x minus e to the x, integral of e to the x is e to the x plus c. All right, so we're going to get e to the x times y, that's when we integrate the left-hand side, is equal to what we get when we integrate this, which we did right here. So that's x e to the x minus e to the x plus c. All right, and then what do? Now we divide everything through by e to the x. And so that is going to give us y is equal to x minus 1 plus c e to the negative x. And there's your answer. All right. So, I mean, you see, it's just the same thing over and over is all it is. The thing that's going to be different is actually integrating this thing. You know, how are you going to integrate the right hand side? That's going to be probably the most, you know, in some cases it might be the most difficult part, but it's not going to be too bad. All right. So what about this one? Well, let's see. We need to divide everything by, it looks like we divide everything through by x squared dx. All right, so that's going to give us dy dx plus, that's going to be 2 over x times y equals 1 over x squared sine x. Oh, that looks nasty, doesn't it? That 1 over x squared, that looks nasty. Hopefully it won't be too bad. All right, so we've got p of x is equal to 2 over x. That's your p of x right here in front of y. And then we've got our integrating factor is e raised to the integral 2 over x dx, which this is what? E raised to the 2 natural log x, which is e to the natural log x squared, which is equal to x squared. So this may not be too bad over after all. So we're going to multiply everything through by x squared, our integrating factor. So that's going to be x squared dy dx plus 2 over x times x squared y equals, now look at there, the x squared's canceling, we're just left with sine x, so that's nice. Okay, that works out pretty good there. All right, so this is x squared dy dx plus 2xy equals sine x. So we've got the derivative with respect to x is the integrating factor times the dependent variable y, which equals sine x. So I just rewrote the left-hand side as the product of the derivative of the product of the integrating factor and y. And so now I can integrate both sides. All right, so this is just x squared y equals, and what's the antiderivative of that? Well, that's negative cosine x plus c. And then we will divide everything by x squared. And so that is going to give us y is equal to negative 1 over x squared cosine x plus cx to the negative 2. And, you know, yeah, I'm writing x to the negative 2. I'm writing the negative exponents with the constant term. I mean, if you wanted to leave it as c over x squared, that's fine. Nothing wrong with that. All right. But there's your answer. All right. So I think we just have a couple more to do. So let's see what we get. Oh, goodness. Let's see, what do we have here? All right, so we already got the dy dx here, so it looks like I'm just going to need to divide everything by cosine. So that's going to give me dy dx equals, well, 1 over cosine is secant x. And then that's going to be minus, that's tangent, right? Sine over cosine is tangent, x times y. And so then what I'll need to do is I'll need to move this over here, because we got to have dy dx plus p of x times y. So that's going to give me dy dx, not equals, plus tangent x times y equals secant x. All right, so let's see what we've got here. We've got p of x is equal to tangent x, and so now my integrating factor. That's going to be, e raised to the integral tangent x dx. All right, so there's a couple things we can do here. So this is equal to negative, this is equal to e raised to the negative natural log of cosine x. All right, which if we take that negative, that's equal to e raised to the, not negative, e raised to the natural log of cosine x, and that's raised to the negative 1, which that's the same thing as e to the natural log of this is 1 over cosine, which what is 1 over cosine? That's secant. And so this is just equal to secant x. So there's our integrating factor. And there's also a property. There's a property that says that e raised to the integral, there's a property that says the integral tangent x dx is equal to negative natural log cosine x. And there's also one you'll see in some calculus books that we can just go straight to that. That's secant x. Okay, the book I teach out of, it shows this, and I've seen some books where it just tells you that it's the natural log of secant. Which one do you want to use? In this case, it would have been better to use this one, but now you know. You can either set it equal to the integral of tangent x, you can either set it equal to negative natural log cosine or natural log secant. Okay. All right. So now let's multiply everything through by the integrating factor. So that's going to give us secant x dy dx plus secant x tangent x times y equals secant squared x. So the left-hand side is the derivative with respect to x of the integrating factor times the dependent variable y, and that equals secant squared x. So this one doesn't look too bad. So we integrate both sides. All right. So the left-hand side is secant x y equals, and then what's the antiderivative of that? Well, that's just tangent x. See that? Plus c. And so now we solve for y. Let's do this first. Let's do this 1 over cosine x times y equals sine x over cosine x plus c. And then all we're going to do, we're going to multiply everything through by cosine x. And so we get y is equal to, the cosines will cancel here. That's just going to be sine x plus c times cosine x. And there's your answer. All right. So that's not too bad there. All right, so this is our last problem. And this is finding a particular solution. If you watched the previous video on separation of variables, I think that was the last example in that video, finding a particular solution. So basically they're giving us conditions for x and y. They're telling us x is equal to 0 and y equals 2. So let's write down the equation. Dy is equal to 1 minus 2y times x dx. All right, so I think the first thing I might do is just distribute this and get rid of the parentheses. So I've got dy is equal to x dx minus 2xy dx. And you see the term with the y, let's go ahead and move that over. So dy plus 2xy dx is equal to x dx. And so now I just need to divide everything by dx and we'll be good. So I've got dy dx plus 2xy equals x. All right. So let's see what we've got here. We've got p of x is equal to 2x. And so my integrating factor is e raised to the integral 2x dx. So that's e raised to the x squared. So there's my integrating factor. So I need to multiply everything times e to the x squared. And so that's going to be e to the x squared dy dx plus 2x e to the x squared y equals x e to the x squared. And so now the left-hand side is the derivative of the product of the integrating factor times the dependent variable y, and that equals x e to the x squared. And then I need to integrate both sides. Let's see, e to the x squared y times dx equals the integral x e to the x squared dx. All right, so the left-hand side is just e to the x squared y equals, and now we've got to integrate this. So, look, if you need to, go to the side and do it. And this is just u substitution. So u equal x squared. So du is 2x dx. So you can see I've got 2x dx, but here I just have the x and the dx, so I need to multiply by 2, so I need to come outside and multiply by a half. So that's going to be 1/2 integral. So I'm going to replace the x squared with u, and the 2x dx I'm going to replace with du. So this is 1/2 e to the u plus c, which is equal to 1/2 e to the x squared plus c. All right, so now let's see, I have this is equal to 1/2 e to the x squared plus c. All right, so typically what we would do here is we could go ahead and solve for y, but we've got our conditions here, x equals 0 when y equals 2. So let's just write that down, x equals 0 when y equals 2. So let's just go ahead and solve for c real quick. So let's plug 0 in for x. So that's e to the 0 squared times 2, because we're plugging in the 2 for y, equals 1/2 e to the 0 squared plus c. So this is going to be, well, that's 1 times 2 is 2 equals, that's 1 times a half is a half plus c. So if I subtract 1/2 to both sides, that's going to give me c is equal to 3/2. So that's e to the x squared y, I'm just writing this down again, equals 1/2 e to the x squared plus 3/2. I'm going to replace the c with 3/2. And then I can divide everything by e to the x squared. And so that's going to give me y is equal to 1/2 plus 3/2 e to the negative x squared. And this is your answer. Okay. So when they give you when they ask you to find the particular solution, you've got to take what they give you for x and y here, and plug it in. I mean, you could have gone ahead and divided through by e to the x squared. I think it probably would. It might have made it I don't know if it would have made it tougher to solve or not, but just go ahead and find C and then solve for Y. Now, you know, that's up to you. You can do either way. All right. So that is all of this video. I hope this helped. Check out my other videos. Give me a like, share, subscribe, comment. Thanks for watching, and I will see y'all in the next one. Later.